Don Larson again. We're ready to get started. So welcome again to our webinar today on technical graphics and converting technical graphics. The agenda today is I'm giving this introduction, and then I'm gonna go through the housekeeping rules for this webinar. And I'll give a quick company overview for those of you not familiar with Larson, and then we'll dive into the actual slide presentation and some live demos, and then we'll wrap up with a summary. And at the end, there will be a Q&A opportunity for you to ask some questions, and then we'll wrap up with some closing information. So for the duration of this webinar, all attendees will be muted. When we go to the Q&A, you'll be unmuted. If you experience any problems joining the webinar or while it's going on, use that little chat box over there to the right. Computer audio is a recommended option for this, but you can also, there's a phone call-in number. We also have some product data sheets, some handouts that you can, little PDFs that you can drag and drop there from the handouts window. So invite you to grab those if that looks interesting. And then you can, again, you can post any questions during the webinar. You don't have to wait to the end to do the Q&A. If you have any questions, if they pop up as we're presenting this information, feel free just to put your question in the question box there. And then again, we'll answer those at the end of the webinar. Larson Software is based in Houston, Texas. We were actually founded in 1984. We're graphics technology experts. We develop powerful, innovative graphics and technical graphics software and toolkits based on open standards. We've been promoting the CGM usage with a free CGM and TIFF viewer, which is going to be replaced this year with a subscription option for those of you that use our VisX reader. We are the first developer of the developer of the first HTML CGM viewer, which eliminates the need for plugins when viewing CGMs in a browser. We're a member of the CGM Open Foundation, and Larson's technology simplifies graphics workflow for technical public professionals, engineers, geologists, and geophysicists, and people working with technical graphics. So with that introduction said, I'm going to turn it over to Dave now for the body of our webinar.
Thank you, Don. Good morning, afternoon, evening, wherever you may be today. Thanks for joining us. So as Don mentioned, this is all about conversion of graphics in various kind of formats, and what we're going to try and do is talk you through some examples of that. So provide some lessons learned with our own experience. And we're trying to make this as generic as possible because we understand you from different industries. But we're going to focus on the common graphic source formats, the raster and vector data, which we'll talk about as we go along. We're going to describe some of the preparations you might need to do and considerations and the techniques you might use to get the best results. And we can also highlight some of the pitfalls of graphic conversion at the same time. So the objective is to provide you with some tips, benefits, advice, and knowledge that you can pick up along the way about the different formats and techniques we're using. And at the end, we'll just summarize the process, both the conversion and, in some cases, transformation of the graphic. So in the introduction, reuse technical graphics produced in varying formats. We still see this as a significant task in the production of your output, whatever that might be, for display or for publication. Different file formats present different issues, and there's different ways to actually resolve those issues. But quality is always the major consideration. You want to get the best you can to give to your customer if it's either published or displayed on a screen. So we'll look at best practice, how you can reduce time and costs. And we have really extensive experience in this area with developing software for the past 30 years in the graphics arena. So just to discuss initially the two main file types we'll be looking at today. So raster, this could take the form of legacy data, so scanned line art images, photographic information, raster files exported from different software, third-party software, more specifically well log images in the oil and gas industry, and also the display of images online. So this is where we find raster files. If you're interested, raster, the name raster originates from the term raster scan, which goes back to the old CRT monitor days. Vector graphics, there's so many sources of vector graphics. It could be 2D or 3D CAD systems, geophysical software from Landmark or Schlumberger, GIS, geographic information systems, mainly things you would see on maps, online maps. Adobe Illustrator, CorelDRAW, talking about the more general graphics programs. PDF, which we've all heard of, obviously a great way of exchanging data that's been around for many years. And also, more specifically, open formats like CGM and SVG that are great for displaying online or just as an archive of your information. So, more specifically, raster data. So you can see from the image there, is usually made up of pixels. These could be just black or white, or they could be in a obviously a photographic image. They would be colored pixels, but basically we have it's a dot. So what we've found is raster data is still playing a very significant role in the graphics production process. It can be used as a source data that we need to convert, but it also could be used as the output. So we still see mainly raster images online, such as JPEG and PNG. It's always good to do the analysis of your raster data before conversion. You can then really optimize that production process. And you have to always be aware of the limitations of raster. Like high resolution files can be very large, even with compression. The quality can be dependent on the source. So if it's been scanned in the past and they've not used the right resolution, then you can get some really poor quality raster images. And scaling, if you need to scale a raster image, then you've got to be aware that it could degrade as you make the image larger. And also, we'll talk about more industry-specific things like raster data might require enhancements of hotspots. So when we're talking about hotspots, this could be something in the technical publications arena where you want to actually distribute your information online and add a sensitive area to the graphics so you can interact with it in some way. Vector data. So again, in varied formats, I would say in the publications arena, then it's preferable to raster. One of the main reasons for that is it can be scaled and the quality is maintained. And this is even true now of displaying it online as well with various viewing technologies, that you can scale it up and you won't lose the quality. Sources of vector data. As we mentioned earlier, this could be a CAD system, geophysical software, GIS software, or general graphics software. So all these are capable of giving you that vector data, but you still might need to convert them into something suitable for onward use. Some of the formats, probably too many to mention in this particular webinar, but some of the more common ones that we see for CAD data, we see DXF, DWG, CGM, PDF. A lot of CAD systems now support PDF. 3D data, too many to mention here. IGES, CATIA, Pro Engineer. There was a native formats, or STEP. So there's so many 3D kind of exchange formats out there. It's just incredible. So you really have to look at those when you're actually bringing them in. Can I handle that data type, or do I need to go to something more generic or open? Common graphics file formats. PDF we mentioned earlier on. PDF can include vector data, although some early PDFs might not do so. It'd probably be raster. SVG, scalable vector graphic. AI, Adobe Illustrator, and EPS, encapsulated PostScript, and also CGM. But CGM tends to be used in a more a niche market. But so obviously CGM is a graphics file format as well. So mentioning CGM, it's open, it's non-proprietary format, actively governed by the CGM Open Foundation. CGM has an ability to contain both raster and vector data, and we'll talk about that in more detail as we go along. It's specifications compliant. It's S1000D and ATA standard, and it's also used in the oil and gas industry as well, using the PIP profile, and it also has a unique extension for seismic data. It's interoperable, which is the main reason it's been actually adopted by these industries. And it supports metadata. So when I spoke about hotspot information earlier on, that's the type of information it contains over and above the graphic information. So things where it contains like a coordinate of a hotspot and actually what it would do when you touch that hotspot. SVG. The use is growing of SVG. It's an XML encoded format, and it's managed by the W3C. Again, it's open as CGM is, and the attractive thing about SVG is it's native to HTML5, so you can easily get an SVG onto the web because it's already supported in the majority of or the popular web browsers such as Chrome, Internet Explorer, Firefox, and Safari. And there's no plugin technology required to display that vector graphic in a web environment. And we've been working hard within our software to support SVG and try and standardize on it because it's such a big actual spec. A lot of the spec is just not really required. And then PDF. So all the ones I've just mentioned, CGM, SVG, and now PDF, are what we call open formats. So they're not proprietary to any particular company. Although you would think so with it, it's still Adobe are very strongly associated with PDF, but it has been since 2008 an ISO standard, which not everybody's aware of. So they actually govern the releases of the PDF format. Again, a good way of being interoperable, moving data around PDF. We would always kind of recommend that now as a good way of getting data from a source program into our software. So PDF is a really good way of moving data around. So what we've come up with today is, for this particular presentation, is what we see as three common scenarios. Raster to vector, vector to raster, and then vector to vector, which on the face of it probably doesn't make much sense, but as we go through it, you'll see what we mean. So raster to vector, this can be confusing in the respect of when we mention this is that a lot of our customers and prospects have this idea that we're actually converting raster data pixels into vector information, and that's not really what we recommend. On the majority of raster images we see, probably the best thing is to preserve the raster and actually embed it within a CGM, SVG, or PDF that all support being a hybrid format, both vector and raster. And then vector to raster, we usually see this where customers want to actually convert their information to go online, so they can have an easy way of actually displaying their information in a web environment. And then vector to vector, probably converting CAD information or from a geophysical software over into another vector format, which might give them some compliance or might give them an easier way to publish the information. So first we're going to look at raster to vector. So we would advise in this particular scenario to go to CGM, SVG or PDF. All of them, as I mentioned, are open formats, and we also describe them as hybrid because they can preserve both the raster and vector data. There are also a lot of proprietary formats out there that will support both, but that could actually cause you data exchange issues in the future if you decide to kind of keep that as your archive. The automatic conversion of raster to vector data, or auto trace, we have a small demo on that later on, and we can show you probably the pitfalls of that. So we're not saying don't do it, but the results can be sometimes poor, and actually keeping the raster might be the best way to do it. And also you can get inconsistent results. If the raster image is really poor, then we always say recreate the graphic using some illustration software. It's probably the most effective way of doing it. And also with you can also add hotspots to the raster data. This is possible even though they're not vectors on there. You can overlay hotspot information, but only really CGM and SVG support this. PDF, although you can add hotspots, it's not an open standard. So we're going to do a short demo. We're using quite a lot of different software today, so hopefully don't confuse you too much. There will be a recording, so you can always go back or ask us questions. So I'm going to use VisX Edit for this first part of the demonstration. So we're going to go from raster to vector. So what I'm going to do is just import some raster information. And this is a form of a TIFF file. Okay, so the quality on this looks good. Hopefully you've seen this on the screen in a good resolution. But this is a raster image. You can see we've got the handles around the outside here. So the good thing is, in this environment now, I've got tools that I can use to actually add vectors. So even though I've got the raster information, I can still add vectors to it, and it actually can go onto over the scan as well. So if I'm to save this now, I can save it as a hybrid file and preserve both sets of data. So this could be an SVG file or a CGM file, and then I can preserve that information. Okay, so I've also got the opportunity in here as well to actually edit the bitmap. So if you had to make changes to the bitmap, you could actually go in here and edit, say, with your favorite bitmap editing software like Photoshop. Here I'm just going to use Paint, so I can just remove some information. So now I'm working with the pixels. I'm just removing this, and I can save it. Oops, okay, what happened? I think it just went to the back, sorry. Oh dear. Let me just bring that back. I think it just went to the back, and I can't actually, so I've got now two running, sorry about that. So let me just import that again. So this is a TIFF file, just bring it in. So I'm adding my my data. As I said before, you can only really use SVG or CGM to retain both. So let's just add the drawing again. So now I've got that hybrid file. So what I'm just going to do is bring up, in this case, CorelDRAW. And this is the same image as before. It's not degraded yet anyway. It's just the way that Corel's actually displaying it on the screen. So you have some tools within Corel the way you can do an auto trace. So if I just select the scan and go to bitmaps, you have various options to do an outline trace or a centerline trace of this automatically. There are quite a lot of different settings you can employ. On here, I'm just going to do, because this has got this kind of technique on it, I'm going to do an outline trace as line art, and I'm going to keep that original size. So in the background here, you can see it's actually doing the trace. So once it's done, we can quickly look at this. We'll just say okay. So on the face of it, looks like it's done a good job, but you might just see here initially it's filled in this circle here. So everything looks good until we start to zoom in a bit on this, and then you can begin to see that if I go right into this image here, it's not quite as good as we would hope it would be. So if I just take this down a bit, I can ungroup this image here. So let me just ungroup. So what it's done is actually grouped everything together, and then I can get down into different levels of this, and we can go in a bit closer. So we're not trying to put you off, or we're just really showing you some of what you will get if you do vectorize it. So you can see here that it's actually made up of fills and so forth. So I pull away here, and we can see how the image has been made up. So so I think if you was just to use it as is, and you were going to use it at the same size, then great, you could use it. But if you're thinking of using this then to edit in the future, then I think that would be not a great idea. As you can see, it'd be very, very difficult to edit this. So really just trying to show you there a pitfall really of using an auto trace package. So actually it's now reappeared. So you can see we did the edit here, and so we have now the image that's actually been edited as a bitmap, and then we've still got our vectors here that we could reopen and then edit in the future. So that would be our kind of advice. This is obviously quite specific to technical publications, but I just wanted to show you how we have a lot of kind of customers phoning, being not confused, but kind of not misinformed perhaps sometimes, that we're actually converting raster to vector, and we have not really found the perfect solution to that as at the moment. So best advice, keep your raster and vector separate data, save as CGM or SVG. Okay, so the other advantage here is that if I keep these formats, is that I have the ability to create hotspots. So in here, what I can do is I can say this particular area, I could hotspot this and say okay, and now I have a sensitive area on the screen. So as we were talking about earlier on about hotspots, again, this is quite industry specific, but with these particular formats I have that advantage. So then I could save this as perhaps an SVG file. Let's just rename it. We'll call it hybrid. And I'm going to save it into this converted folder here. Now I should be able to bring that back up and quickly show you the result. So I just need to go to my folder. So I'm going to just double click on this and it will actually appear in Chrome. So when I hover over here, we should see that tooltip that I just put in cylinder. Here's our vector. You know, we could actually reduce the line weight here and it would look more like the actual scan image. Okay, let's go back to our slides. To move that out of the way. So the next one is vector to raster, the next scenario. We see the primary reason for this is to probably publish the graphics online, because this is just the easiest way to do it. And it's also the easiest way to exchange data, because these are really common formats. The thing to be aware of is that you can lose quality in this scenario. So your end solution is really going to dictate the requirement to convert. We would say ideally keep the files in a vector format if you want to display them online. So you can just see that we just used SVG, or you could use CGM as well. We have as Don mentioned at the beginning, a HTML5 solution for viewing CGMs online without a plugin as well. So, and that's kind of an out-of-box solution. Hotspots become a bit more difficult because of the fact that you can't contain the hotspot information within the raster file. So you would need some kind of an image map to hold those particular coordinates of the hotspots, and then your viewer has to be capable of interpreting those. So for this demo, I'm going to use VisX Pro. VisX Pro is kind of our flagship CGM viewer, CGM and TIFF viewing solution. But it can open various formats, so it's not limited to CGMs. It can also open DWG, DXF, EMF, and TIFF files. So it's really useful just as a little kind of standalone solution for converting from one format to another. Okay, so what I'm going to bring in is this DWG file. So this is a CAD file. I can't really edit within VisX Pro, but what I can do is now save it as a JPEG file. So let's just save that into our demo folder here. So I'm going to save this as a JPEG. So this is a really easy way of getting this DWG file into a format that then could display perhaps in a web environment. And then I can open a CGM file. So this is more specific to the oil and gas industry. So I've got this seismic log here, which then again I could save this time as a PNG file. And perhaps I could display that in Chrome or something like that. So let me just see if I can find that. Unfortunately, I've got so many windows open. So I've got PNG. Oh, in fact, let me just do that again. So PNG tries to open in the viewer from Microsoft, which is not good. So let me just open that again. So you won't see much difference here. Oh, sorry, that was the DWG one. So you can now see them in Chrome. So I've immediately taken that into a web environment. Okay, so let's just. So sorry, there's so much going on, but I've got a lot of software that I need to actually show you for these demos. And the final thing I mentioned was bitmaps and actually hotspots. So let me see if I can bring in. a file here. This is back into VisX Edit again. Sorry, my software seems to have, my computer seems to have slowed down. Let me just see if we can bring it back up. Okay, so let's just open that again. Say CGM. And we've got this exploded view. And you can see on here there's quite a lot of different hotspots. So if I now save this as a TIFF, I have the ability to save this with hotspots. Even though it's a raster file, I have the ability to save this with hotspots. And what that will mean is it will create what we call an image map. So it'll actually record all the coordinates of where those hotspots are as a companion file to the TIFF. So we save that out, and what will happen is that it will also create a spreadsheet with all those coordinates on. So that would have to be interpreted by a viewer, but it's a really good way of getting that information out, even though it is a raster file and not kind of the intelligence of the SVG or CGM formats. Okay, so that's scenario 2. And that was using VisX Pro, and we actually use VisX Edit as well in that particular demo. So vector to vector. This is our final scenario. So where would you use vector to vector? I think it could be from various sources. So you might want to get CAD data in, as we did with the DWG a few seconds ago, and reuse it in a different environment. Things to be aware of here with CAD information is that sometimes it will contain what we call polylines, or little straight lines to make up a curve, and this can be really bad when you're actually trying to then distribute the file, because it increases the file size substantially. Also makes it impossible usually to edit as well. And then we have import from general graphics programs. Probably recommend PDF to do this. So you might want to go from the general graphics program into, say, for instance, CGM for onwards distribution, or SVG. Our caveat on this is SVG is, we found, because we've done a lot of work on our conversion filters, is that it's very inconsistent from a lot of programs. So we'll probably use, better to use probably PDF than SVG if you're exporting out of general graphics programs. And also a common scenario is you want to get this into a standard, such as PIT for the oil and gas, or S1000D for defense and aerospace applications. So this is a common scenario where you want to have a compliant file. And then finally, that hotspots again is that you could automatically add hotspots to these, as we've seen earlier, to CGM and SVG. Those are the only ones that can really support it. If you're using PDF, then you have to go in and kind of manually add that data as a layer later on. So for this one, I'm going to use our kind of standalone converters to show you some of the processes we have here to go, because usually this is something that has to be done in a batch mode. It's usually trying to get a lot of files from one format into another. So let's look at CGM to vector to begin with. I'm going to just close some of these windows down so it's not as busy on the screen. Oh. Okay. So this is quite a straightforward interface. I'm going to go to options first, and this is where I really choose my format. So what format do you want to go to? So this is obviously specific to CGM as well. So we have a lot of customers who want to go to SVG because it's probably the most straightforward way to get it onto the web. What I can do is here choose the output directory, which is already should be set up. Let me just double check that. So I'm going to go to so I select my folder. I want these to be SVG files. I've got other settings in here as well, but for this particular demo, I'm just going to actually just do the conversion. And I'm going to add a folder. And I'm going to use this particular, so these are all CGMs here. And then I'm going to do the conversion. So this is a really quick process. There's 39 files here that it's going to do. And it's actually complete already. So let me just, we'll see if I can pull this folder onto the screen so we can actually see it. So here's the SVG files that I've just converted, and you can see they've actually been associated, SVG's been associated with Chrome. So if I just double click, I can immediately bring this up and you can see the image that's actually in there. So this is obviously in the Chrome browser. So very straightforward to do that. The quality should be good. We're not going to lose quality. So there's not as many kind of pitfalls, but it is really just moving it from one format to another, usually for a particular purpose. The other option I had here was to go to PDF, which can be extremely useful as well. I'm just going to change the target directory for this. But I'm going to use the same files as before. So I'm going to convert all these as well. So now converting to PDF. So let's just go back. And here's the same image now in a PDF file. So quality is not an issue because we're going from one vector format to another. So we're retaining that quality, but we're just using it for a different purpose. Okay, just minimize this. And the final part of the demo is we're going to show you a PDF to CGM. So again, this is quite common in the oil and gas industry, and also in technical publications industry as well, because say for the oil and gas, one of the requirements is to take the PDF, which has got multiple pages, and actually then create a CGM file, which is the standard for the industry, into one CGM. So it's actually going to create a well log and combine all those pages into one picture, which is really impressive. And then I say the technical publications industries, because you could have a technical manual as a PDF, and you want to extract all the graphics out of that as CGMs. So this could be some legacy information, and now you want to create a separate CGM for each of those graphics inside that manual. So really, two applications. Today I'm just going to do that one. It's always difficult to find examples that we can actually use as well. So what I'm going to do is just see if I can, there's the file name, output directory. I think I'm just going to use the same one and say OK. Let's do that conversion. But so you can see here, there's actually 96. Actually, this PDF is 96 pages. So you can imagine how long this is. So let's convert. So it takes a bit longer, mainly because it's doing quite a lot of work here. So let's just see if I can bring up that, get my... So once it's completed, I'm hoping it's going to go into that directory. So refresh. It's working really hard. Let's double check that this went into the right one. Okay. For some reason it's not gone into there. Okay, we might just have to miss that bit, unfortunately. I think it's still doing something, to be honest. Okay. We might be able to go back to that during the Q&A. Don might be able to help me with that one. Okay. So that completes the demo and the scenarios. Just to kind of reiterate, the software that we've been using is VisX Pro, VisX Edit. We didn't show VisX Transform today, but we did show CGEB to Vector. So VisX Pro is really our viewing software, but can be used to convert single files. So we saw CGM and TIFF, DWG today, and then you could save as JPEG and PNG. VisX Edit is our illustration software. So again, single file conversion, but it gives you a lot more flexibility. We support a lot of file formats in there. Plus you can actually edit the graphics as well. VisX Transform is a multi-format converter. Bit too probably involved to show everything today, but you can see it actually supports a lot of different formats in there, and it also does auto hotspotting of the files. And then we looked at some of the single batch converters today. We looked at CGM to vector and PDF to CGM. So with those, obviously quality is not as big a thing with the ones we showed, but it would be if you're going from image to CGM, perhaps DWG to CGM as well. So you see in the interface, it's really straightforward, and that's the desktop version. But if you've got repeating conversions you need to do, we also have a command line version and SDK as well, which are really popular if you want to integrate this into a process. So in summary, you can see there's a number of source formats and output formats that you might need for your general workflow. They can be challenging depending on your source data, the quality of it, and also the formats as well themselves. So the primary considerations we always see is what's the source and output format you require, or what's available, the quantity of the data, how much do you need to convert, is it a one-off conversion or is it a repeat process, and a hotspot's required. Do you need to add metadata to those files, because that's going to dictate what formats you use. Selecting the correct software can be a challenge. Obviously, we've been in the business quite a long time, around 30 years, so we've got good experience. There's a lot of free stuff out there, but in our experience, because we look at it all the time, it's not always doing what it says it does. And all the licenses you see and software you see today, you can actually evaluate and test if you go to our website. So we hope you've found that interesting. And now open up to Q&A. I think Don might join me again at this point. I've got a question here. Does the auto trace then create a true vector graphic, either CGM or SVG? The auto trace, it was not in our technology, it was in Corel. So, but the answer is yes to SVG, but no to CGM. Like the standard Corel doesn't support CGM. And like I say, there's probably issues downstream if you use that method. And then there was another question, funny enough, on Corel as well. It says, does the centerline trace eliminate the fill problem? And probably the answer is yes, but it probably won't eliminate the fact that you're going to get something that's really difficult to edit still, because it'll put arbitrary points all over. So that's probably a good choice. From my experience using the auto trace, I think it's really good for general graphics, like if you're trying to recreate a logo or something like that. That's quite straightforward. It's very useful and quick. But for technical illustrations or for something like a well log, or I wouldn't even go near it. Does Vizex Edit now support bi-directional languages like Arabic and Hebrew? So I might leave that with you, Don.
Yes, the answer is yes. Yeah, we just added that just recently, in the last 6 months, the ability to do languages, Arabic or Hebrew, that can go right to left. So yeah, you can. It does support that now.
Okay. So if you're a user of the software, and what we'd recommend is just send us an email, and we'll make sure you can download you've got the latest version. I think that would be the easiest solution there. Don, did you see anything that went wrong in the demo part with when I did the conversion of the well log? Because it doesn't seem to be there. So
yeah, well, I think it's wherever your PDF is. You need to find where the PDF. Oh, there's the PDF.
Oh, there you go. That's it.
Yeah. So there's
there's the CGM. So
right,
it's the wrong directory. So let's open it now. I'm going to open it in Vizex Pro. I'll try to. There we go. There you go. So you can see, we can't really see anything other than a line going down the middle, and remember, it was 99 pages. So
yeah, you can click on that scale to width right there.
Yeah.
In the toolbar, there you go. That's right.
Yeah.
That's typically what's used for logs.
Okay, so it did work. It was just a typical demo that you're trying to do. So you can see that it's really stitched all those 99 pages together. So you could see that to do that task would be almost impossible if you were trying to do that in any other software. Okay, so I'm pleased it did work. It was just a user error. Thanks, Don. So if you have any, so I think that's the questions we've had for today. It's always very difficult to explain this, as you can see again with auto trace, is that it's kind of the holy grail sometimes of vectorizing raster images, but we found that unfortunately the best solution is usually, certainly in the technical illustration arena, is to actually just keep them as raster images and then edit them or add to them. We just got another question, sorry. What is the best option to display a CGM picture in a web browser? Convert to PNG or SVG, or use a CGM viewer plugin? Well, we have Don did mention the technology at the beginning. I think if we go to, we would say the best solution is obviously our own, which is Vizex View HTML5, which allows you to view a CGM in a web environment without a plugin. So we would say don't convert to PNG or another JPEG. Try out our Vizex View HTML5 technology. So you can request an evaluation here, or just send us an email and we can send you a link to do an evaluation. So no plugin required. In fact, if I scale down a bit here, this is an example actually of using our plugin using our technology without a plugin. Okay, we just had another question. What are the best options to display a CGM on iOS and Android? Same technology. This is cross-platform. So visits view HTML5 again. You can view, you can see down here, we can view it in mobile friendly. So iPad, Android, tablets. So CGM files in a web environment or online environment or mobile using visits view HTML5. No need to convert those CGM files. I hope that answers your question. Oh, we've had another question. Okay, is a converted raster to vector image a smaller file size than a hybrid conversion? That's a good question, and I couldn't really give you a definitive answer because it could vary. Really, it depends on your raster and your vector files. So. I would say the danger is it's probably going to be bigger because the vectorization could actually cause you to have a lot of points on there or handles or that could actually increase the file size. So I don't know if you've got a take on that, Don?
Yeah, that was my thoughts too. Now, the center line, the question related to center line is probably relevant here. If they could be converted to lines rather than paths, filled paths, those could be smaller, but my experience is the vectorization still puts so many points, and then to represent a point in a vector language takes a lot more, takes like 20 or 30 bytes to describe 1 pixel as a vector in vector language, whereas in bitmap language, only one bit of a byte. So, yeah, it's a complicated question. We could probably run some. Maybe Dave and I could run some tests, maybe, and get back with you on that because it's an interesting question. And but I think, yeah,
it really depends. I think on your data as well.
Yeah, that's
it's kind of really. It's kind of how long is a piece of string because it would. It depends on the source data, really, and how the quality of that source data. There's so many variables.
Right. The other downside, too, of converting raster to true vector is it doesn't vectorize the text. In other words, text is just a big polygon, each character. So then those are not very useful. So it's not searchable, which ultimately that's one of the goals sometimes of converting it to vector is to make the text searchable, or be able to hotspot it, and it won't do that, unfortunately. Now we do have some technology that BizX transform will actually OCR the text when it's converting it to a hybrid file and put true text into the file as metadata that's searchable. So like Dave said, it's complicated, but we'd be glad to have more discussions about this offline and see if we can help you make some decisions.
Yeah, it's such a common question to us as about vectorization, and but our advice is really retain what you have, and if it's really poor quality, the raster, then probably the best bet is to recreate it. Because if it's usually the reason that people want to do vectorization is the quality of the scan is poor. The thing is, if it's poor, then your vectorization will be poor. So there's no kind of magic button that's just going to make these kind of scans into really nice graphics, or vector graphics. So we're really happy to help people and advise people and see if our technology can help. And provide advice where applicable. The best thing to do is always test that scenario out. Okay, thank you, Don. And thank you for all the questions. That was really kind of you to put those forward, and hopefully we answered them. So we've already visited CGM Larson to look at the Visit View HTML5, so cgmlarson.com. There will be a link to a recording that will be sent tomorrow, so if you want to go back over some things that we covered today, then or distribute that out to somebody, a colleague, then they'll get that email tomorrow. All the materials will be available on slideshare.net. They won't be quite there yet, but again, tomorrow they'll be there. You can follow us on LinkedIn and also on Twitter. And also, topically, we did mention Visit View HTML5. We will be having the 2019 workshop. This will be our third one on this technology that you can attend. Invites yet to be sent out, but they will be going out probably in late March, early April. So thank you for attending. Sorry about a few glitches, but there was a lot of software that we was moving between today. Hope you enjoyed it. If you have any questions, then please contact us and we'll be very pleased to help you. Enjoy the rest of your day. Thank you very much.